So, hello my dear, I welcome you again in this series of GSB. So, in this series, this is the second part of fluid mechanics, and this subject is also important for both mechanical and civil. So, the first, so if you are not able to watch the first part, you can watch, and the description link it is given below also in the videos. So, today we will discuss the second part. So, in the second part, this is all the basically it is the problem practice. Okay. So, we will discuss the first problem. Yes, why we are taking this problem? Why? Because beta, I know that in this problem lots of confusion is there. Lots of confusion. Why? I will discuss this thing. So, this is the first question. Today's first question. Okay. What is that? The force F. This is the this is the figure. In this one, this is your piston, inverted piston is there, piston, and this is your cylinder. So, piston and cylinder is there. Now, piston and cylinder is there. Now, my dear, the fluid will present over the platform. This is act as a platform. So, the fluid is present in this cylinder and it is holded by this piston. So, to hold this fluid as it in this position, we have applied the force F vertically upward. We have applied the force F vertically upward. This dimension it is given, this length dimension it is given, this total dimension it is given. This area, cross section area A, capital A, and this cross section area is small a, it is given. Okay. Then they are asking what is the force required to hold the fluid in that position? What is the force required to hold the fluid in this position? My dear, thank you very much. Thank you. So, this is the force. Now, my dear, this is a very simple question, but the simple question, why there is a one confusion, the student who are moderate, that will solve and they get correct marks, but who is students are very intelligent, they get confused. Why? Why? Because you know that this is the platform, okay, this is the platform. So, generally, thank you. So, generally, this platform, the fluid it is present. So, what is the weight of the fluid? What is the weight of the fluid? That weight will be holded by F. So, this F is what? Weight of the fluid, number first. So, if you calculate the weight of the fluid, that is exactly equal to the force F. But there is a problem. Let's try to that, okay, that concept. So, my dear, this is your platform. Let's suppose this is at equilibrium. So, we know that at equilibrium, this F, force F, number first, this is the first category, this is the first method. Force F is equal to what is the pressure? This pressure, once again, what is the pressure will exerted by the fluid on this platform. So, let's suppose this pressure will act by the liquid on the platform. So, this is the pressure P. Now, my dear, so we know that this pressure force is equal to what? This pressure into the area of this piston A. That is good, no problem. There is no problem at all. Yes. So, this P is what? This P is what, my dear? This P, it is nothing. It is your hydrostatic pressure. Yes or not? Hydrostatic pressure, and this is nothing. This is your hydrostatic pressure force. Static pressure force, there is no any problem. That's it, there is no any problem. Okay. Thank you everyone, beta. Today is a very good problems. What I have managed a problem select kiya, what the problem I am selecting, that problem is a very good problem. So, it is not matter to solve the problem, the matter is to think inside. So, this is the hydrostatic force. So, this is what? Hydrostatic pressure force. So, my dear, what is this hydrostatic pressure? What is this hydrostatic pressure? Density of the fluid, G, and height from the free surface. What is the height from the free surface? How much it is? Capital H. Basically, this is your H height up to this one. This height up to this height. Okay. So, rho G into capital H. Now, if you multiply with, so what is the value of hydrostatic force? F, which is holded, rho G H into capital A. That's it. So, if you take, see this option, rho G H A, yes or not? So, your answer is, that is okay. Your answer is rho G, no, not this one, rho G H A, this one. So, that is correct option. But what is that? Thank you everyone, welcome to you all. So, rho G H, that is a correct option, but think different manner. Now, let's suppose beta, we are solving this force according to the weight of the fluid which is present over this platform. So, but force, very important, force acting on area A is same as the weight, you can also try the weight acting by the fluid, yes or not, by the fluid. You can also try to solve by the fluid. So, by the fluid on this area, So, what is the force? This force is equal to nothing, it is a weight. Yes, the force, it is nothing, it is the weight. So, it is the weight W. This force is nothing, one second, this is your W, weight W. This force is nothing, it is a W at equilibrium condition. So, this weight, and weight is what beta? Mass of the fluid which is contained within this part into G. And what is the mass? Density into volume of that fluid into G. So, this volume is what? This volume is what? This volume is what beta? This volume is nothing, it is the volume of fluid which is present in that portion, And what is the portion, my dear? See this thing, very important, see. This is your lower one, this is your lower one of area A, this is the area A. We apply here the force F, and here there is a one which is attached to this one, and in this one there is a fluid. All are in this one there is a fluid. So, what is the weight of this portion? That is equal to the F. So, how to calculate this weight? So, volume. So, volume is what? Volume is, let's suppose we have to design like that. Okay. So, we have to find volume of this green portion, volume of this green portion. This is the green portion. Volume of this green portion. Yes, this volume of this green portion, this portion, volume. So, how to find volume? Total volume minus, so what is that beta? This is the total volume into capital area minus, this is a small area A. So, capital area minus a small area into height, this height it is given. This height is small h, and this height is your capital H. So what is the volume which is fluid present? What is the volume which is fluid present? That means rho g you have to take outside. Total volume is what, beta? Area into height. Area into capital height H. This is capital H. Minus capital area minus of small area into this height small h. So in this portion is the volume of the fluid which is present. This is the portion total volume minus volume of this portion minus volume of this portion, my dear, minus volume of this portion. So total volume capital area into this total height minus of capital area into a small area divided by into h. That is the volume of this portion, left portion. So that is the total weight which is exerted on the platform, and that weight will balance by this F, force F. So if you calculate this one, beta, rho g a h minus a small h plus a small h. Yes or not? Now if you take a common, this force F, rho g into a h minus you take common, minus of h minus small h into a. Yes, it is right. A h minus of, yes, correct. A h, okay. A h, no, it is not like that. It is like that. 1 second. Take a common. So this a h minus of a common, minus of this a common. 1 second. 1 second, my dear. This is correct. A h rho g into total volume a minus small a into h, correct. This is correct. Now so h a minus of h a plus h a. So this is your okay, no problem. So you have to just 1 second, just see, compare this thing. What is that previous answer? What is the previous answer? Previous answer is this force is equal to rho g a into h. Yes or not? Yes or not? Now this is the force due to the weight, and both are calculation wise correct. This is also calculation wise correct. This is also calculation wise correct. But this value, that means the force due to the weight is less than force due to the pressure. Yes or not? Force due to the weight, see, rho g h a, there is a minus term, so this will reduce. So force due to the weight is less than force due to the pressure. But the calculation wise both are same. So there is a confusion. Why not this is correct? Why not this is correct, beta? This is also correct, no problem. Where is the problem? Please tell me. That means there is an exception. This is called hydrostatic paradox. That means, hence we can say that, sir, force due to the pressure, force due to pressure is more than force due to weight. Yes or not? So both value wise differ. Both value are differ. But the calculation wise it is correct. Calculation wise it is correct. So this is called hydrostatic paradox. what is called hydrostatic paradox, called hydrostatic paradox. That means if you calculate the hydrostatic force, just apply rho, g, h and h from the free surface, that's it. That's it. That means, so simply apply for that one, simply apply hydrostatic law. So what is the correct option? This is your correct option. This is the according to hydrostatic law. Okay? Sai Kumar. Okay, beta, it is clear? This is clear now? So this is first problem for the hydrostatic law. There is another concept is that, let's suppose my dear, there is a bridge, dam is that, okay? In this dam, up to this level of water is there. Okay? So what is the hydrostatic force? That is the same hydrostatic force. What is the hydrostatic? Same hydrostatic, rho g h. Now let's suppose same dam, but the layer it is only thin layer, very thin layer. It is supported. What is the hydrostatic force? Let's suppose this is height h. This is also height h. This is also height h. So on this one, hydrostatic force, if you calculate hydrostatic force, F is what? Rho g x bar. X bar is what? X bar is what beta? H by 2 into area, vertical projection. Similarly, in this one hydrostatic what? Rho g x bar, that means h by 2 into vertical projection. Now my dear, see, it is practically possible कि ये ब्रिज, ये डैम इस अमाउंट को वाटर हाइड्रोस्टेटिक फोर्स दे रहा है, ये ब्रिज देयर इज अ वेरी थिन लेयर ऑफ वाटर गिव्स द सेम हाइड्रोस्टेटिक फोर्स, it is true reality? Reality, it is not true. Why? Because to construct this dam you have to make stronger as compared to this one. If you construct this dam आपको strong बनाना पड़ेगा इसके कंपैरिजन में. But both dam experience the same force. It is not possible. That is also a hydrostatic paradox. That is also called hydrostatic paradox. Clear now? These are the things which is related to the hydrostatic paradox. So this is my first question. Now before going to the next problem, we will discuss some features of IMS. What is that? See, there is a, if you join test series, this is not a test series plus. Why h by 2? Why? Because with the why? Yes, Surya. Why h by 2? Why? Because with a hydrostatic force, that means if you calculate the hydrostatic force F, that hydrostatic force is your centroidal pressure into the area. What is that? Centroidal pressure. So where is the centroidal pressure? Pressure is what? Rho g h. But that centroidal pressure is what? Rho g, not total h, pressure at the center. Let's suppose this is x bar into the area. And what is the x bar here? Cg. This is the x bar is the location of Cg from free surface. Location of Cg from free surface. So this x bar is what? Simply h by 2. This is the formula of hydrostatic force. If you join regular class, we will discuss this thing. This is the hydrostatic force. So rho g h by. Now it is clear, beta? Surya, it is clear? It is clear now? Okay. So this is the things. So both have a same hydrostatic force but it is not practically possible. So this is also called hydrostatic paradox. What is called hydrostatic paradox? Clear? Now, before going to the next problem, we'll discuss this test series plus. This is plus, my dear. What is the plus? If you purchase this test series, instant you get the discount of 20%. And what is the benefit in this test series? With 130 online test series is there. How much? 130 line, 30. And also, you get 33-year GATE PYQ technical and 33 GATE PYQ math plus aptitude. That means these two are a different book. This is different, this is different. And mind it, there is a 33. And what is the unique features? It is not simply the GQ question, PYQ question booklet. In this booklet, there is a QR code. The problem which is tougher, or the problem which is very confusing, and or the problem which is in many sources have a many different answer, for that one, we are providing the QR code. On that QR code, there is a video solution. So you can get the video solution very easily to understand the concept. This is the unique features. Number 4. Third, number 4, doubt solving portal. You are access the doubt solving portal also, where you have to ask anything. Online revision and score booster is there, like today's. Post GATE guidance, also you have to get the post GATE guidance also, and also the mock test interviews of different PSU. That means you have this much of that access you have. That means अगर आप परचेस करते हैं टेस्ट सीरीज प्लस को, तो आप इतने सारे आपको बेनिफिट्स मिलेगा. Okay, now this is the slide for the live online program. If you join the regular course, there is some features. What are the features? We have provided 800 plus hour of live classes with live interaction. Second, you also get a theory book, exercise book. In this theory and exercise book, there are 4,000 plus questions. Mind it, there are 4,000 plus questions. And beta, also this is not 34, this is your 33. 33 year of GATE question bank with a video solution. Already we told you. Now there is one unique feature is that in this question booklet, there is not only one solution. Sometime in some question, there are more than 3 solutions. Method 1, method 2, method 3, method 4, like that. Sometimes, some questions. Maximum question you can get alternative solution and also key point. So complete package is there, and also you have to get a 12 personalized one-to-one mentorship session. That means in this situation, in this steps, student directly connect with the faculty one-to-one, and they can ask anything what they have any confusion or anything. There is supposed to be preparing anything, and when they feel any difficulty, they can. Okay, and also 133 online tests with video solution, and all the test solution that अगर हर एक टेस्ट सीरीज के सॉल्यूशन का आपको वीडियो सॉल्यूशन प्रोवाइड किया जाएगा. Clear? So these are the things. And if you want to free counseling, you can click directly this link, or you can call this number. They can entertain you and guide better than. Okay. Now go to the next problem. Okay, this is very good problem again. See my dear, बेसिकली मैं ये चाहता हूं कि आप लोग को आपको थोड़ा सा इंप्रूवमेंट मिले. मतलब द क्वेश्चंस विच आई एम डिस्कसिंग हियर, दिस इज नॉट सिंपली ए क्वेश्चन. along with the question, I will give you high dose of concept, related concept. Okay, so see this problem it is there. Mind it, beta, this problem is very good problem. Calculate the force F required here to hold the gate in a closed position. Okay, now my dear, what is the situation? There is a tank. This is your tank. In this tank, there is oil and there is a water. Up to that, there is a water. So there is oil and there is water. All are have a flat surface, but the corner one is your quarter circle. This is your quarter circle. This is your quarter circle. And this gate, this is a gate, and here it is a hinge. Here it is a hinge, my dear. This is your hinge. This point, it is your hinge. So what happened? So at this point, this gate we will swivel up and down. It will be, it's like that. It will be swivel like that. Why? Because this is a pressure. Mind it, this is the question related to, it is not a free surface. It is a closed surface. That means this is not a free surface. This is not a free surface. It is a closed container. Mind it, this word. Now, this gate have a width of 1.2. This is the width, 1.2. So, what is the force required to hold the gate in that position? What is the force required to hold the gate in this position? Okay. So, my dear, my question is that. My first question is that, what is your first step in this problem? Please tell me. What is your first step? Very first step. What is your very first step in this problem? Please tell me, beta. Anyone, please? If you know, then please tell me. What is your first step? What is the first step of this problem? I'm not telling that you solve this problem. What is the first step? I will give you a timer for 1 minute. Oh, for 1 minute, okay? For 1 minute, just think, beta. Just think. And tell me. My question is that, what is the first step of this problem? Please tell me. What is the first step? Pressure variation and the horizontal force balance. This is not a first step. It is not a first step. The first step is that, this is, what is this F? F is your hydrostatic force. F is what? Hydrostatic force. And to calculate the hydrostatic force, you want the free surface. You want the free surface. Without free surface, you cannot calculate the hydrostatic force. So we create a imaginary free surface first. Imaginary free surface first. So first, if you calculate the imaginary surface, why? Because this container is a closed, pressurized container. So what is the pressure at this point? We have to calculate. Once calculate the pressure at this point, and we know that pressure is equal to rho GH. Once you have the knowledge about this pressure, you can find head rho G. You can find head H. And this head you can find, and then you have to draw a imaginary free surface. This is the first thing. Not a datum line, beta. That is not a datum line. This is pressurized. So this pressure equivalent to this pressure, how much this fluid column, that column you have to design up to the free surface. Then you have to find the free surface, then you have to calculate. This is very good problem, I am telling you. No, between the, no, it is not like the draw a data. No, don't want to draw anything here. Just calculate this pressure P. Once you have to calculate the pressure, you can find the head. What is the head? How much this equivalent head we will develop? And then you have to define a free surface. That means the first step is that to define free surface. to define free surface. To define free surface. For defining the free surface, we want H, and H is equal to P by rho g. So first is to find P. What is the pressure? For finding of the P, this is given with a. Otherwise, you cannot find. Previous problem, study problem, there is also a container, closed container, there is overhead container. So, and that closed container, we have to find the pressure. So, for that one, there is a overhead container is there. Same problem is that. Now, so how to find? To find the, that means this is what? Pressure at the top of box. You have to find pressure at the top of box. How to find? Apply manometric equation. Apply manometric equation. Okay. So just apply manometric equation, my dear. Here, what is the pressure? Here the pressure, let's suppose P. Here the pressure is P. 1 second, we have to take one black color. Here the pressure is P. At this point, pressure is P. So P, manometric equation, we are applying the manometric equation. P plus, you are moving down in oil. So this is your specific gravity of oil, it is given 0.8. So 0.8 into density of standard fluid, that is water, 3, into rho g 9.81 into height. This height is how much, beta? This height is how much? This is your 6. It is given. This is your 6. This is also 6. This is your 6. Okay, na? This is also, oh yes, this is 6. This is 6. This is 6. So this is 6.6 meter. This height is 0.6 meter also. 0.6 meter. So rho g into h. H is what? 0.6. So you are where? You are at this position. You are at this position. Now again move down in water, plus water density 10 to the power 3, 9.81 into this height. At the sea, throughout water. So this is also water. In this one there is a water. So up to this height, rho g h. H is what? 0.6 plus 0.2 plus 0.6 and plus 0.2 and plus r. R plus 0.2 plus 0.6. That is the total height from here to here. All are the water. So rho g h. H is what, beta? H is what? You can take like that. H is what? 0.6 plus 0.2 plus r. R it is given, beta. R it is 0.6 again given it is. So R. And this R it is given 0.6. Clear? So you are at here. Now you can jump here. Directly you can jump. Why? Because there is same fluid. So you are here. Now move up. Minus. In this one there is a mercury. 1.3 into 10 to the power specific gravity 3 rho g 9.81, and what is h? H is r, that means 0.6. So you are at here and it is open to the atmosphere. So it is all are in the gauge form. So the atmospheric pressure P atm, and we are writing in a gauge form. So this P atm is 0. Why? Because gauge pressure. This is our manometric equation. Now, if you solve this equation, we can easily find the pressure at the top of box. How much? Please tell me. Take a time. How much it is? I will write here 16.61 cross 10 to the power 3 Newton per meter square, or you can say that 16.61 kilonewton per meter. This is the pressure. Now, if you have this pressure, you can easily design the head. What is the head? This pressure is what? This pressure is rho. What is the rho? Here it is oil. So rho of oil GH. So from here H is what? P by rho oil into G. So what is P value beta? The P value it is 61.61 cross 10 to the power 3 divided by rho 0.8 cross 10 to the power 3 G 9.81. If you solve this head, it is your approximately 7.85 meter. 7.85 meter. What is this? This is what? This is your free surface. This is your H. That means this is your container. So this container, so you have to move this, you have to move up to here, from here to 7.8 meter, and that create the free surface. How? Please see. Please see. One second, color will change. Okay, we'll take this color, no problem. So from here you can move H height and draw a free surface. This is your free surface. How much height? 7.85 meter. Now the calculation, and there is a fluid in this side. There is a fluid, and this fluid is an imaginary fluid up to this portion. That means if you design, take this one, up to this portion you have to design. So this is the imaginary fluid, my dear. Above the curved surface, this is your imaginary fluid from the surface. So these are the imaginary fluid. It's not a real fluid. Why? Because the curve, this is a curve surface. So here it is a fluid, but here it is not. So this is an imaginary column. Now all the calculation, hydrostatic force calculation, we calculate from the free surface. So we create a free surface. Okay. So so this is a curved surface, my dear. This is your curved surface. Okay. This is your curved surface. Okay. From here to here, we have created a imaginary surface. There is a force F you have applied, and this is your hinged. This point is hinged. Okay, and this height is how much? ऐसे ही बढ़ाओ यार. Okay, so sorry for the delay. Somewhere there is a technical issue. Okay, now it's okay, done. So we have to find the free surface. Now the calculation wise it is same. Now we have to find the free surface. Now my dear, there is a force F here, and there is a hinge. There is a hinge here. This is your hinge. Now we have to create a artificial free surface. Artificial free surface. That height h is equal to 8 point how much? 7.85. 7.85 meter, and in this one there is a imaginary fluid column. Why? Because here is the fluid, yes or not? Here is but this is the imaginary fluid column concept. So this is the up to this. What is this? This is radius. This is radius. How much? This is radius, na? This is radius. So this is how much? 0.6 meter, and this is your point H. Okay. Now my dear, we have to calculate what is that force, this F required. So this F, my dear, see this F we have to find this F value. So this this is your what? This is your what? This is your weight imaginary. This is your first. This is your imaginary surface. So this is your imaginary surface. Imaginary surface, and this is your imaginary surface. Now we have to find first horizontal force. Why? Because beta, why? The pressure will exerted on this curved surface by this fluid, that is the volume vertical force. Why? Because if you find hydrostatic force, this is a hydrostatic force. Why? Because curved surface, the hydrostatic force is a concurrent. So all hydrostatic force meet at a point. It's have a two component. One is the vertical component, other one is the horizontal component. Yes or not? Let's suppose there is any resultant R, any resultant F. This F have a two component, FV and FH. And what is the vertical force? Vertical force is nothing. It is the weight of this imaginary fluid up to the free surface. This is the vertical force. What is the horizontal force? Vertical projection of this curved surface. Vertical projection of the curved surface. So if you find horizontal force FH, rho G H bar into area projection. Area projection. And this area projection, it is in vertical direction. So if you find this horizontal force, this is the area projection. This is the area projection. Project this curved surface vertically. Okay. So in this one, what is this? Oil. Yes or not? There is oil, na? In this one, there is oil. So density 0.8 cross 10 to the power 3 into 9.81. Now, what is H bar then? What is H bar here? Please comment. What is H bar here? Here, student sometimes confused. That's why I'm asking. Please tell me what is H bar here? Write the numerical value. What is H bar here? H bar is the CG from the free surface. This H bar is what? CG of vertical plane. Vertical plane from free surface. From free surface. So let's suppose this is the point. This is the point where it is a CG. This is the point of CG. And this is CG up to the free surface. Up to the free surface, this is H bar. So H bar how much? This H plus 0.6 by 2. This H plus 0.6 by 2. Understood? So this H bar here is your H plus 0.6 by 2. H is how much? 7.85 plus 0.3. So this is how much, beta? 7.85 plus 3. Okay, we'll write this thing, no problem. This is H bar. And what is the area projection? What is the area projection? What is the area projection? This width into this height, that is the area. This is the vertical projection. Na? So this is the width and this height 0.6, that is the area, and width it is given. Width in this question it is given, beta. Width, get width 1.2. 1.2 width it is given. So area projection is what? 0.6 into width 1.2. This is the area. Now put this value here, 9.81 into h bar is 7.85 plus 0.3 into 0.6 into 1.2. If you solve, this is your 46.05 kilonewton. This is your horizontal force. Okay, Surya, correct me if I am wrong. We took free surface on right hand side, clear, and extended the same fluid, one second beta, extended the same fluid above the curved surface. Now, since I know that pressure variation completely on left side direction, I mean above the curved surface, since the curved surface is static equilibrium, we make a horizontal force to be same. Horizontal force, see what you are asking, see my dear, what is that? This is your curved surface. This curved surface, if you take this force F, one second beta. So Surya, there is the things that we have we calculate the horizontal force. Why? Because this force will be exerted, this force continuously changing. So there is a resultant force, horizontal force. So this horizontal force will act on a vertical projection. And this vertical projection is below the free surface. This is not at a free surface. It is below the free surface. Let's suppose this is a free surface and this is a plane. What is h bar? H bar is the CG from free surface. That's it. From free surface. There is no any problem. Yes. And this, there is a fluid. In this side there is a fluid. So it will create a horizontal force. What is the problem? I think it is clear now. Okay? If you have further confusion, you can message. Okay? I will explain you. No problem. So this is a horizontal force. This is a horizontal force. Now, we have to find the vertical force also. So vertical force is what? Weight of the fluid. Vertical force is the weight of the fluid. Weight of the fluid. So vertical force, Fv, is the weight of imaginary fluid. Weight of imaginary fluid. And weight of imaginary fluid is what? Density G into volume of the fluid, which is in this portion. This is the portion. So my dear, rho G, how to calculate this volume? How to calculate this volume, my dear? Please tell me. How to calculate this volume? If you calculate this volume, total volume minus volume of semicircle. Total volume minus volume of semicircle. Okay? So, total area minus area of quarter circle into width. Into width. That is your volume. Into width. That is your volume. So, rho G, Fv, rho G is what? 0.8 into 10 to the power 3 into 9.81 rho G. Now, what is the total volume? What is the total volume? Total volume, this total volume, this height into this height, area, First calculate total area. This height plus this height is the area into this height area into width is the volume. Okay, so in right hand side, oil exerts some force on the curved surface. Okay, right hand side, yes, it is okay, curved surface. So to counter, if we apply the same force on the curved surface, yeah, yes. Why? Because this is the hydrostatic force F. Okay. Now you have to calculate this force F, but this force is F is balanced by this horizontal force. Also there is a weight. Why? Because beta, see, one thing is very important. See, if this is your flat surface, very important. If this is your flat surface, what is the horizontal force? Same force you apply, that is okay. If this is not a flat curved surface, it is a flat surface. So how much the force is applied? That same force, what is the hydrostatic force is applied? That is okay. But this is a curved surface, my dear. This is a curved surface. So on the curved surface, this F, we have to calculate the resultant. Why? Because on the curved surface, there is a horizontal force and vertical force. We have to calculate the resultant. We have to calculate the resultant. And why we are calculating the, you are saying that sir, this F is equal to Fs, so that is the answer. No, it is not like that. It is not like that. There is a resultant. We have to take the moment at this point. We have to take the moment at this point. So this F into this, and there is a resultant force. So how to calculate the resultant force? Why? Because this is a curved surface, and curved surface exerts a resultant force. Resultant of horizontal force square root plus vertical force square root. Fh square plus Fv square ka square root, that is our horizontal force. That is our resultant force. That resultant force will also exert. So if this F is not, this F will creates a moment, and that moment is balanced by the resultant force moment. Okay, na? This moment, this creates a moment in this direction. So the gate is closed. Now the fluid also creates a moment. Why? Because fluid exerts a force on the curved surface. And the force on the curved surface, it is not only horizontal, it is vertical also. So we calculate the resultant force. Now it is clear then. Surya, now it is clear? If it is a flat surface, then it is okay. If it is a flat surface, there is no any problem. But there is a curved surface. On the curved surface, not only horizontal force act, also vertical force. So we have to take a resultant and take a moment of resultant at that point and balance it. Then we have to find the force F. Okay. So total area is what? 7.85 plus 0.6, this is the height, total height, into total height into this width is your 0.6. Okay. Now this is your total area minus of area of quarter circle, pi by 4 d, pi by 4 r square, 0.6 whole square, quarter circle na, so pi by 4 quarter circle, pi by 4 into width, so this is your area, all multiply with the width, and width is what? 1.2. This is clear? This is your total area 80 minus area of quarter circle into width, that is the total volume. If you calculate this thing, the vertical force is 45.08 kilonewton. Keep asking, Surya, keep asking the question. That is a very good habit. Okay. So this horizontal force. So we have calculated. We already calculated the horizontal force and vertical force. Horizontal force and vertical. So what is the resultant? Resultant force. This resultant force R. This resultant force is why? Because both are perpendicular. Fh square plus FV square. Square root, if you take this square root, FH is your 46.05, 46.05 whole square plus 45.08 whole square. If you calculate, this is your value 64.44 kilo Newton. Now the concept started. Now the concept is started here. That is the simple calculation, basic calculation. Now, my dear, see this thing. Okay, see this thing here. This is very important slide. 1 second. 1 second. We have to write here. No problem. 1 second. See, this is very important. Don't read. Not putting red. Fill color. Fill color is your white. Border is red. Okay, no problem. So see this thing, Vita. This is very important calculation now here. See, what is that? This is your curved surface. This is your curved surface. Quarter circle. There is hinge. We have applied the force F. Okay. Now, this is your hinge. This is your hinge. And how much this distance? This distance how much? 0.6 meter. Yes, this is 0.6 meter. And see, my dear, the force, this is a point. The force which is acting, resultant force, what is the force will act on this curved surface, that all are concurrent at this point. So let's suppose different forces. Let's suppose there is a different forces, my dear. I will just clear all the things, please. This force is concurrent. This force, it will act and it will pass at the same point. This is the difference between flat surface and curved surface. This is the force, and this will pass at a point. In this, all the forces, this is a resultant force. So there is one resultant. These all are the resultant force. But there is a one resultant which have this value. So let's suppose this is one resultant. This resultant FR. FR here. Now, my dear, this FR, so we have to calculate the moment at this point. So this force into perpendicular distance. This force into the perpendicular distance. We have to take a perpendicular distance. So we have to draw here one line. To draw here one line from here to here. This is your perpendicular distance. This is your perpendicular distance. So this force into this arm length, this force into this arm length. This is also 90 degree. Now what is this value then? What is this value? We have to calculate this value. We have to calculate this value. So this, let's suppose this is angle theta. Angle theta. How to find theta? How to find theta? Position of the resultant force. That means we have to finding position of resultant force. What is the actual position of this force? So tan theta, we are taking angle from vertical. So FH by FV. So FH by FV, if you calculate theta, it is approximately 45.57 degree. This is your theta. Once you have a theta, you can take a component. So what is this length? This is your radius r, yes or not? 0.6 meter. So take, this is theta. So what is this? 0.6 sine theta. This length is what? 0.6 sine theta. Are yes or not? Yes. So taking a moment at point O is equal to 0. This is point O, let's suppose. So this force into distance produced anti-clockwise. So this force into 0.6 anti-clockwise, and this force into perpendicular distance, it is produced clockwise. So equal to this Fr into 0.6 sine theta. 0.6 sine theta. Put this all value. So F into 0.6, Fr is your 64.44 into 0.6 sine of 45.57 degree. So if you calculate this, F is equal to 46.01 kilonewton. Clear? Clear? Clear na? So this is the concept. So what is the concept in this one? We have to create first artificially free surface. Then we calculate horizontal force and vertical force. Then we calculate a resultant hydrostatic force. Then we have to balance the moment at point hinge. Clear? Everyone, please. So this is the concept of this problem. Okay? This is the concept of this problem. Now, let's decompose. F resulted into x and y component. While taking a moment about hinge, only x component contributes the moment. No. Not x component. No, not it like. Sir, let's decompose the resultant force. Yes, we can decompose this resultant force. Clear? This decompose into the x component. So this Fr have a x component. What is that? Fh. Y component is what? Fv. Yes, Fh and Fv. That's why we are finding the location of this theta. While taking the moment about the hinge, only x component contribute the moment. No, this why? X. This is the force, resultant force. Resultant force have a unique angle. So we take a perpendicular distance. What is the perpendicular? Otherwise you cannot take a moment of resultant force. So this F into moment anti-clockwise, this force resultant force into moment. अगर आप डिकम्पोज करते हैं, yes, अगर आप डिकम्पोज करते हैं, let's suppose you are decomposing vertical and this is horizontal, FH and FV, तो वहां प्रॉब्लम आ जाएगी. क्या प्रॉब्लम आएगा बेटा पता है? What is the problem? Horizontal force, you have to find horizontal force, and where this horizontal force will pass? Why? Because you are taking this moment. So you, if let's suppose this horizontal force passing, and what is the distance of this one? First calculation, that is your center of pressure. So first calculate the center of pressure for horizontal force moment. Then for vertical force moment, you have to calculate the CG of this semicircle from the base. From the base, you have to calculate the CG of this semicircle. So this F into distance, this FH into the, let's see, like that. We'll understand. See, very good question. See, my dear, I will just explain you, no problem. This is your curved surface. This is your curved surface. So this curved surface, there is a hinge. Here is the force F. Clear na? Here is the force F. Now there is a resultant Fr, which an angle theta. This have a component Fh and Fv. Clear na? So we have to take the moment. Let's suppose this distance is x. So F into x at point O. This force will be a vertical projection. This horizontal force will act at a vertical projection. So what is the This is a free surface. So what is this height? This height is H, center of pressure. So first calculate the center of pressure. So this force into this height. So it will create anti-clockwise. It will create clockwise. So minus FH into HCP. Now the vertical force, this is also clockwise. So minus FV, and this will pass. Vertical force is what? Weight of the fluid, and weight it is at CG. So we have to find the CG from the base. Let's suppose this is Y. So FV into Y, that is equal to 0. Then we have to find F. So why? Because beta, why this is lengthy? Why? Because you have to find HCP, you have to find Y. That's why we find the resultant. Why? Because resultant included both horizontal and vertical force. So to calculate, this is okay. What you are asking, this is okay. But there is an extra task we have. There is an extra task. First is HCP, and then second you have to find the CG of semicircle from the base. Then you have to take the moment. Okay, Surya? Now it is okay? You are right, but that process is little bit lengthy. Clear? I think it is clear. So your answer is that your question, the answer of your question is that we can find this one, but this is little bit lengthy. Why? Because in this one you have to find SCP, you have to find Y. Okay. Now that is okay. Done. Now the next problem. Yes, this is the next problem. This is the next problem. Please read this question. The plug. This is your plug. Similar type of question already asked in the gate. That's why we are taking intuitionally this problem. The plug. This is your plug. This is your plug. Rectangular plug. This is your plug. The plug of 50 mm long, that was perpendicular to the board, 50 mm long. This is type of plug. This is your plug, beta, and this plug is 50 mm long. This plug is 50 mm long, perpendicular to the pitch, and this is cross section. This is cross section, and it is inserted into the hole of this container. There is a orifice in this container, and we put this in this one. Okay, long and has a trapezoidal cross section. This is a cross section is trapezoidal. If the tank is filled with the crude oil, this is crude oil. Determine the resultant vertical force. Determine the resultant vertical force acting on the plug due to the oil pressure. Acting on the plug due to the oil pressure. So my dear, I will give again 1 minute. Just think. What is the approach? That is the very important. Please, what is the approach? Time's up. Okay, let's start this problem. See, my dear, very important. This is your plug. This is your plug. Okay. Now this plug is fluid is this plug fluid holds. By this plug fluid will holds. So what is the surface which is encounter with the fluid? Upper surface. This is your plug. See. This is your plug. Yes. So the fluid which is upper, it will exerts a pressure on it, upper side. Okay. And up to here, again there is a fluid. This is a fluid. Here it is a fluid, na? Side. Again this edge, that means this edge also held by the fluid. Now this edge, this is your edge in which the fluid will encounter. Now this edge is inclined. So in this inclined surface, here is the pressure, here is the pressure. So this is a pressure variation on this surface. On this surface, this is the pressure variation. Yes or not? And this pressure variation have a two component. Let's suppose this is a force on this, so this force in a vertical direction and there is a horizontal direction. This also a force F which have a horizontal direction, which have a vertical direction. This horizontal will cancel out. This horizontal force will cancel out. Only the vertical force is there. So this, due to this curved surface, due to this slant surface, due to this slant surface, a vertical force will produce, vertical hydrostatic force. Why? Because net hydrostatic horizontal force, net, that means component, what is, see, what is FH and FV? This is the component of hydrostatic force. So the component of hydrostatic force F. So this F have a two component. So horizontal component FH and FH will balance. Only the vertical component. So this is FV, FV. So total upward force is 2 FV and total downward force is this one, above this fluid. On this one, what is the pressure? What is the pressure? The fluid is holded. So take this curve surface over the free surface. This is a free surface, over the free surface. So this much amount of the fluid, volume of this fluid is holded by this surface and which is act in downward direction, which is act in downward direction. So this curve will hold this fluid. Now, so what is the vertical force of this one? FV, FV, this vertical force, FV, FV, which is downward. Rho G into volume of that fluid. Why? Because this is the weight. How much this will be holded? This is the weight. Vertical force is what? Weight of the fluid content above the free surface. Horizontal force is what? Centroidal pressure of the projected area. It is like that. So there is no horizontal force in this case. Only the vertical force downward and two vertical force is upward, and both are balanced. So that the plug, it is in equilibrium. So this is now, so rho G, what is the volume? This volume is what? This height 60, what is the volume? This height 60 mm, that means 0.06 into this length into this one is what? 40.04 into width. This is area into width, and width it is given 50, that was 0.05. So this is the total, this is the vertical force due to this surface. Clear? Clear now? This is the vertical force, and it will act downward on this surface. Now, here is the fluid which is exerts 2 of vertical force, which is upward. How to calculate this vertical force? Take this surface, this is the curved surface, this is the surface, and if you take this surface, 1 second my dear, this is one surface which is encounter with the fluid, this is another surface which is encounter with the fluid. Take this surface up to the free surface, take this surface up to the free surface, take this surface point up to the free surface, take this point up to the free surface. So what is the weight content within this fluid? That is the vertical force, and this vertical force is upward, and this vertical force is upward. This vertical force is upward. So what is the volume of this one? What is the volume of the 2 into area of trapezium? This is what trapezium. 2 symmetric trapezium is there. So 2 into area of this trapezium into the volume, into the perpendicular length, that is the volume. So 2 into volume of trapezium, and what is the trapezium? That means volume of trapezium is what? Area of trapezium into width. What is the area of trapezium? Let's suppose this is trapezium up to this height, up to this height, up to this height, up to this height. So this is, it is visible now? It is visible, yes, up to this height. Okay. So what is the area of trapezium? Half parallel side, sum of the parallel side into the gap x, let's suppose, into the gap x. This is the area. This is the area. So area is what? Half into this distance. This one is how much? 0.606 plus this distance is 0.075 into this distance. This distance is how much? 0.01. This is the area. This is the area into width is how much? 50. That means 0.05. This is the volume. Multiply with the 2. That is the total vertical force. So in this one, this direction vertical force. Why? Because it will here. So vertical force component like that. And in this fluid, it will produce downward. So that is the net vertical force. That is the net vertical force. Okay. So net vertical force is upward or downward. See, this is very minimum and this is maximum. So net vertical force is downward. In this case, net vertical force is downward. So F net vertical is equal to this area rho g take common into 0.06 into 0.04 into 0.05 minus downward 2, there is 2 now. So 2 into half of this one 0.06, 0.075, 0.01, 0.05. Write this here. And then this is your answer, and answer it is your 0.453 Newton. I will repeat again. If there is any problem, please ask me. Please ask me. There is a simple funda. It is like that. See. This is your trapezium. Any shape. Here it is a fluid. Up to that, there is a fluid. Simple funda up to that fluid. Someone asks you, what is this force required? So this force F is a vertical. This is your hydrostatic force at this age. Why? Because fluid is there. It's have a two component, this one and this one. It's have a two component, this one and this one. So this is FV1. This is also FV1. This is FH and FH is cancelled out. Okay. Now there is a pressure over this surface. If you calculate the vertical force, take this is a vertically upward. So this is the volume of this fluid, and this will act downward. And if you calculate this volume of this encounter, take this is your free surface projection, take this your free surface projection, so this much, and it will act in this one upward. In this one, take the vertical projection, take the vertically up to the free surface. So it will also act upward. So if you take a net, this two upward minus this one, so it is net is downward. That will be balanced by this force F. So you can calculate like that also, no problem. You can calculate like that also, no problem. If there is a circle plug, let's suppose this is there, and if there is a circular plug, you can easily calculate. Take this. There is a horizontal cancel out. Take this vertical projection. Calculate the volume of this one. That is the force, net force. So one problem related to the plug you can solve from your textbook or anywhere. Okay. So these are the types: circular, trapezium, triangular plug. So you can solve this such type of portion. Okay. Now next. Yes, this is the next problem. Please read this question. A cylindrical wooden pole is there, 20 centimeter in diameter. The cylindrical wooden pole is 20 centimeter diameter and 1 meter height. Height is your 1 meter. Is placed in a pool of water in a vertical position. Vertically, the specific gravity is 0.6. Then it will be, what is the condition? Floating in a stable equilibrium, floating in unstable equilibrium, floating in neutral equilibrium, and start to move horizontally. So for that one, I will give you again timer, so that you could just think. Just start. Okay, time up. Now, this is the related question to the buoyancy and flotation. They are also very good problem. So, we will have to solve this problem first. So, what is that beta? There is a cylinder. Okay, this is your cylinder. Let's suppose this is your cylinder. 1 second, we will discuss here, no problem. This is your cylinder, vertically placed. Listen very carefully, no problem. Vertically placed, and this is your center line. Okay, and it will be floating. It will be floating vertically. It will be floating in the fluid. Okay, see how it will placed in a pool of the water in a vertical position, and there is a water. Let's suppose this is your water. There is a water. Let's suppose it will place like that. Okay, it will place like that inside the water, and it will be float. And the property of the wooden cylinder, it is given a specific gravity. Okay, now now my dear, so this is what? This is what? This is your plane of rotation. This is your plane of rotation. It will be tilt like that, like that, like that, like that. Plane of rotation. This is called plane of rotation. And this height it is given, this dimension it is given, my dear. This dimension it is given, and this total dimension it is given. Okay, this dimension it is given 20 centimeter, and this total it is given 1 meter. Okay, now this is our x-axis. We are taking at is x-axis. Always it is always like that, x-axis. So this is what? This is our z-axis. Z-axis. Now, my dear, this is our cross section of wooden cylinder. Yes or not? Wooden cylinder, and this cross section of wooden cylinder is called plane of rotation. This is called plane of rotation, and this plane of rotation is in which plane? X and Z plane. Okay. Now, if you are saying this top, so if you are saying this, if your view of this portion from the top, so from the top it is a circle. From the top it is a circle. From the top it is a circle. This is your circle. Oh, 1 second. This is circle, my dear. Now, this have a axis like that. This axis and this axis. Okay. This is what? Which axis? X axis. And please tell me what is this axis, beta? Please tell me, everyone, what is this axis? Z axis? No. You are saying here. 1 second. 1 second, beta. So this is your cylinder. You are seeing from the top. So top is what? Circle. And this is what? Plane of flotation. Plane of flotation. This is plane of rotation. And see, this is the cylinder, na? So it will be float like that. So top is what? Or a top is what? Plane of flotation. And if you cut this one, that is the plane of rotation. So this is your plane of rotation and this is your plane of flotation. So this is called plane of flotation. Plane of flotation. This is called plane of flotation. And plane of flotation is in which plane? X and Y. Why? Because beta, see, this is our cylinder. This is our Z axis. This is our Z axis. This is our X axis. So this is our Y axis. This is our Y axis. So Y axis always appear in the plane of flotation. If this plane of flotation rotating about X axis, that is called pitching. That is called pitching. If the plane of flotation is rotating about Y axis, that is called rolling. And if the plane of flotation is symmetrical, so the rolling and pitching both are same. Okay. Let's suppose this, it will dip inside the water of height h. Of height h. Of height h. Now, so my dear, this is your initial process. This is a what, beta? Equilibrium. What is the equilibrium condition in the floating? What is the equilibrium condition of the floating? The equilibrium condition of floating is weight equal to the buoyancy force. The weight equal to the buoyancy force, number first. What is the condition of the equilibrium body? What is the condition of equilibrium body? There are two conditions of equilibrium body. First one is the weight of the body is exactly equal to the buoyancy force. Second, very important, the line of action of the weight and the line of action of buoyancy are collinear. There are two conditions. Weight is equal to buoyancy force and the line of action of weight and the line of action of buoyancy both are in a collinear. That is the two conditions of floating. Okay. Now, so this is symmetrical. So let's suppose there is a CG here. This is CG. So CG at what distance, beta? Obviously CG at 1/2. Yes or not? 0.5 meter. This was CG. And the portion which is inside, that is the fluid displaced, and the CG of the buoyancy force is what? CG of the fluid displaced. So this much amount of the fluid is displacing. So CG of this one is what? Here. This is buoyancy, CB, center of buoyancy. And this center of buoyancy is from a small h/2. Small h/2 either this side or either this side. This is your 0.5 either this side or this side. This is the CG. From the CG, there is a weight. Through the buoyancy, there is a center of buoyancy CB, FB. So this is your weight of the body and this is your buoyancy force. And this is your buoyancy force. So at equilibrium, my dear, in this question, the first task is, such type of question, the first task is find how much the depth of immersion. How much the depth of immersion. First find how much the depth of immersion. So to finding the depth of immersion, since the body is in equilibrium, that means the weight of the body is equal to the buoyancy force, and weight of the body is density of body g volume of body, and buoyancy force is the density of water. Always buoyancy force is due to the water, fluid, water g into volume of fluid displaced. Always keep in mind, if the body is fully immersed, this volume of the body is the same as the volume of fluid displaced. So this g and this g will cancel out. So density of body is what? Specific gravity, it is given 0.6. So 0.6 into 10 to the power of 3, it is a density. And volume of the cylinder is what? Pi by 4 ds square into height. So this is your pi by 4 d 0.2 square into h, total 1. This is your volume. That equal to density of water 10 to the power 3. This is water, na? Pool of water, yes. 10 to the power 3. And volume of fluid displaced, pi by 4 d square into what is the height h. If you equate this value, these two value, we can easily find the height submerged, and that is your 0.6 meter. That is your 0.6. This is the first line. This is your first line to find the submerged depth. So now, my dear, this submerged depth you have, okay. So this is your CG, this is your CB, okay, and this is your base, let's suppose. So from this one, this is your 0.5, this is your 0.6, 0.5, okay, CG 0.5, and this submerged 0.6 meter. CB is, oh, CG is below, G is below. G, in this case, G is below the CG, B, okay, no problem. So H, so CB is what? Center of buoyancy is what? H by 2, H is what? 0.3. So this is 0.3, no problem, 0.3. So what is this distance? B and G, 0.2 meter. B and G is what? 0.2 meter, okay, na? 0.2 meter. So BG, distance between the center of buoyancy and gravity is 0.2 meter, okay. Now, if you find the stability condition, if you are finding the stability condition, what is the condition? We know that metacentric height let's suppose this is metacenter M, this is CG, this is center of buoyancy. So GM is your metacenter, and this GM is equal to BM minus BG. BM minus, this is your metacenter over which the body will float. Now, this BM is what? A very important calculation of BM. So BM, distance between the center of buoyancy and metacenter, this complete, we have to find from, there is a direct formula, I, moment of inertia, y divided by volume of fluid. Volume of fluid displaced. Very important. What is this IYY? This is circle for the, this is circle na? Circle IYXX or IYY is same, no problem. So either you have to put here IYY or either you have to put IXX, there is no problem. But you always keep here a minimum value. Okay. So this is your second moment of inertia. Second moment of area moment. किसका? Second moment of area किसका? Of the plane of flotation. Okay, very important. Plane of flotation about centroidal axis. And this centroidal axis, that means this plane of flotation is always is always perpendicular to the plane of rotation. This is plane of flotation. This is plane of flotation. This is the plane of flotation which is perpendicular to the plane of rotation. Clear? About the centroidal axis which is perpendicular to the plane of rotation. Clear na? Clear? And this is volume displaced. So what is the moment of inertia? Pi by 64 d4 for circle. Volume displaced pi by 4 d square depth of immersion. For that one we have to calculate depth of immersion. So this is your d square by 6h, 16h. If you put this value back, 0.2 square, 16 and h is 0.6. So this is your 4.16 cross 10 to the power minus 3 meter. This is your BM. This is your BM. Now, if you find then GM BM is equal to 4.16 cross 10 to the power minus 3 minus BG and BG how much? BG is 0.2. See my dear, this is your minus 0.019 meter. That means less than 0. That means M below G. That means M below G. If M below G, the body is unstable equilibrium. That is M below G, and that is your unstable equilibrium. This is your unstable equilibrium. So my dear, float with a stable equilibrium, float with unstable. Option number C correct. Yes na? Option number C correct. Clear? Please tell me. Clear na? So such type of question they are supposed to be asked. Okay. So how to find? First find depth of immersion. Then find BM, distance between buoyancy and metacenter, with this formula. So for that one you remember the moment of area, moment of inertia. Otherwise a very difficult to solve. So different geometry if you supposed to be given. So you have remember, मतलब आपको याद रखना पड़ेगा कि ये moment of inertia different shape का क्या होता है. Okay. So we have to calculate BM. Now this is the condition. This is the equation to check whether it is a stable, unstable, neutral. That means if GM is greater than 0, that means M above G, m above g, stable equilibrium. If gm less than 0, m below g, unstable equilibrium. If gm equal to 0, if gm is equal to 0, that is called stable equilibrium. Neutral equilibrium, stable equilibrium, unstable equilibrium, neutral equilibrium. So gm is equal to 0, that is your neutral equilibrium. Okay, done. Now next problem, and mind it beta, this is very good problem, also important. This is very important problem. Okay, read this question. A weight of 10 ton, a weight of 10 ton is moved over a distance of 6 meter. There is a weight, and that weight will move for any circumstances up to 6 meter across the deck of the vessels, and the weight of the deck of the vessels is 1000 Newton, which is floating in the water. This makes the pendulum length, ऐसा होने से the length of the pendulum is 2.5 meter, swing through a distance 12.5 centimeter. Horizontally, the metacentric height of the vessels. Take a time, just think. I will again give you timer. चलिए स्टार्ट कीजिए. टाइम अप. ओके, सबसे पहली बात तो ये है कि इस प्रॉब्लम को समझना ही थोड़ा डिफिकल्ट है. समझना कि कहां से ये पेंडुलम आ गया भाई. सी देयर इज ए प्रैक्टिकल, देयर इज ए सिचुएशन. सी दिस इज योर डेक. सी दिस फिगर. सी दिस वन. एंड देयर इज ए कार्गो, देयर इज ए weight. This is ship, very important. Here is the post. See this post? So this post, there is a pendulum. There is a pendulum. This post, there is a pendulum. It will like, initially it is a this position, and this is your pendulum over it, and it will be fixed at this post. इस post पे ये fix रहता है. So if the ship is horizontally moving, the pendulum is exactly at the center. Now, due to some circumstances, that means, let's suppose, what is that? There is a cargo, there is a weight, it is there here, over put a weight. And this weight is your 10 ton. Due to some circumstances, this weight will move up to 6 meter. This weight will move up to 6 meter. Initially it is balanced. Now after some time it will move at 6 meter. So if it will move at 6 meter, so let's suppose this 10 ton, let's suppose this way ship will tilted a little bit. So if the ship will tilted little bit, so this post will be tilted. So if this post will be tilted, the pendulum will be swing. The pendulum will be swing. This weight will try to produce a couple, applied couple. It will produce a applied couple. So if it will produce a applied couple, that means the weight is W1 and into this 6 meter. It will produce a couple. And this produce a couple, that means torque, and this torque will try to tilt the ship. So how to measure this tiltation? This is very minimum. If you are on the ship, you are very difficult to say that there is a tiltation. So there is a pendulum. So if it will tilt, this post, it is like that after tiltation. So this pendulum will be in this position. After tiltation, this position. Now, this is angle of swing, theta. So this is saying that this makes the pendulum length is how much? 2.5. This pendulum length is 2.5 and swing through a distance 12.5 centimeter. So it will swing from here. Initially this is the position. Now from here to here, it will swing 12.5 centimeter. This is the question. Then they are asking that the metacentric height of the vessels. What is the metacentric height? What is the metacentric height? Let's start. So see, this is your ship. So over there is a post and this is a pendulum over. If the ship will tilted at any circumstances, this pendulum will try to make that. So this is angle of swing, this is shifting, and this is pendulum length like that. Okay, so we'll discuss this thing, no problem. So my dear, initially this is our free surface. Let's suppose this is our free surface. This is our free surface, my dear. Now, this is our initially ship is there. Let's suppose initially this is your ship and there is a weight will placed here. Let's suppose the condition it is given, this weight, let's suppose W1, it is given 10 ton and total ship weight W2, let's suppose it is given 1000 ton. This is your central axis. Initially. So initially there is a buoyancy. Initially, my dear, there is a buoyancy somewhere in this one. FB always act upward, and there is a weight. There is a weight, total weight. So let's suppose this total weight is W, and it will pass at CG, and the buoyancy force FB, it will pass at center of buoyancy B. And initially, it is in equilibrium. Initially, it is equilibrium. So at equilibrium, this buoyancy force is exactly equal to the weight. This buoyancy force is exactly equal to the weight of the body. Now, my dear, due to some circumstances, and here is the pendulum. Here is the pendulum on the post. Now, due to some circumstances, this weight will shifted at somewhere, let's suppose 6 meter. 6 meter this weight is shifting from this point 1 to this point 2. Due to that, the ship will tilt. Due to that, the ship will tilt like that. Due to that, the ship will tilt. This ship will tilt, and during the tiltation, this pendulum make an angle theta. Make an angle theta, and this length of the pendulum, it is given how much? 2.5 meter, and this is how much it will be swing? 12.5 centimeter. It will be tilted. Now, theta is your angle of heel, sometimes called angle of heel. Now, my dear, if it will be shifted from this one point to second point, on the ship it will be applied torque. Applied torque. So here it will apply the torque, so it will be tilt like that. So how much applied torque? Please tell me. This torque, student confused here. Torque is what? Force into perpendicular distance. So what is this force during the applied torque? Who is responsible to apply this torque? This weight W1. Who is responsible to apply this torque? Weight W1. So W1 into this distance. This is your torque. Applied torque. Now, so here we can easily find what is the angle of heel, theta. So tan theta is equal to this height to this height. That means 12.5 centimeter into 10 to the power minus 3 minus 2 divided by 2.5. So if we calculate the theta value, it is 2.8 degree. 2.8 degree is the angle of heel. 2.8 degree is the angle of heel. That means this is your tiltation edge, tilting edge, my dear. Okay. This we have to draw like that, little bit far. 1 second. 1 second, 1 second. No, don't worry. So let's suppose this is your angle of tilt. So my dear, this is your new position. Let's suppose parallel to this one. We have to draw a line diagram. So here, initially this is your B. Now, here the large volume will emerge inside. So center of buoyancy will shift. So let's suppose that there is an initial point B, and it will shift at B dash, from where the buoyancy force will pass and it will intersect this line of action after tiltation, and that one is your nothing meta center. This is your meta center. It will be a meta center. And what is the consequence of meta center? Through the meta center, this is the point of meta center along which the ship will oscillate. So this is also angle of theta. Okay. Now there is a center of gravity G, let's suppose. So this is your G as it is. G. From this G, the total weight pass center of gravity, this total weight, and this total weight is what? W is equal to W1 plus W2. This total weight is passed. And this is your arm length. So this W1 into this into 6 meter, it is your applied torque. And this weight into this distance, restoring torque. This is restoring torque. So what is the restoring torque? Let's suppose this is X. So restoring torque is W into X. At equilibrium, both are balanced. At equilibrium, both are balanced. So summation of all the force moment, all the moment at meta center is equal to 0. So let's suppose this is W1 into 6, it is a clockwise. This is your anti-clockwise. Restoring torque, W into X. W into X. What is X, my dear? What is this X? What is this X? Please tell me. This X is how much? GM sin theta. GM sin theta. This X. So this X is your GM sin theta. And GM is what? Meta centric height. Yes or not? Height. Now, what is W? 10 ton into 6 meter. What is W1? 1000 plus 10 ton into GM sine 2.8 degree. 2.8 degree. This ton is cancelled. From here, we can easily find GM, and this GM is equal to 1.2 meter. 1.2 meter if you calculate, and that is your positive. GM is what? Positive. That means stable equilibrium. That means if the ship will, on the ship, if you apply the torque, automatically there is a restoring torque, and the restoring torque is more than the applied torque. That's why the ship again it is in normal position. Again it is in normal position. Clear this question? Please tell me. This is clear now? This question is clear? So that is the concept. This is a new question, okay? That is the concept of all the things. Clear? Okay? Now we will discuss the next problem. अरे भाई आप लोग सब ठीक है ना? कोई प्रॉब्लम तो नहीं आ रही? अगर प्रॉब्लम आ रही तो बता दो. ठीक है? Okay? Done. Now, the next part is your kinematics. This is very good question again. I will read the question first. The velocity of a gas particle flowing along the center of the pipe. This is your pipe, and a particle will flowing, gas particle, at the center of the pipe in the figure is defined for x greater than equal to 1 meter by the velocity field. This is field, it is given beta. By the velocity field, this is your field. Velocity field, it is given. Where t it is in second, x in meter. If the particle is at x is equal to 1 meter, when the particle position is at x is equal to 1 meter, we have to start the counting of time. Time is equal to 0. Determine the velocity at x is equal to 2 meter and acceleration of a particle at x is equal to 2 meter. Clear? So I will provide your timer. Start. Please think. And this is very good problem, I am telling you. Done? Time up. Let's start. Beta, as you know that the difference between Lagrangian approach and Eulerian approach. What is the difference? The difference is that, I will tell you, that is a very subtle concept. Lagrangian approach is a particle approach. That means you identify the particle, track the particle, and we have to describe that particle motion like that. That is your Lagrangian. Eulerian, we are not track the individual particle, rather than we are fix the control volume, and we will see what happened inside the control volume. We are not bothering about that, what is coming inside and what is from where the fluid is coming inside and from where the fluid is going outside. We are focusing the camera settle at the region and we are analysis the region. That is your Eulerian approach. Let's suppose you are on the roof, आप छत पे हो इवनिंग के टाइम में और आप देखते हो ऊपर, आप देख रहे हो क्या कि there is a bunch of the bird is flying. Yes or not? That bunch of the bird, approximately bunch of the like 20, 50, 100 birds are flying in a group, and you identify the whole bird. That means you identify a region, and then you think that yes, that bird is flying, many bird is flying, and then you think that is your Eulerian approach. Now you take the one bird and fit the chip on that bird. मतलब एक ट्रैकर फिट कर दीजिए बर्ड के पैर पे, उसको छोड़ दो. Now bird is flying, so you are identify a single particle, a single bird. That is your Lagrangian approach. So if you analyze the group of the bird, that is your field, and if you analyze a single bird, that is your particle. So the field approach and there is a particle approach. There are two types of approach: field approach, particle approach. Field approach, it is a Eulerian description. Particle approach, it is a Lagrangian description. Number first, second. Number third, field approach, it is a control volume analysis. Particle approach, it is a control mass analysis. Now, essentially, the Lagrangian approach and Eulerian approach will merge when the fluid particle have a same density, या property, या velocity that of the field velocity. Let's suppose the fluid is flowing and you are tracking individual particle. Let's suppose the density of that fluid particle and the density of that field is the same. Then the Lagrangian approach is exactly equal to the Eulerian approach. That is the beauty of things. So there is a merging. The merge of a Lagrangian and Eulerian approach when there is a particles, track the particle the same property as that of the field property. In that sense, essentially the Lagrangian approach will merge to the Eulerian approach. Otherwise, both are different. So one is the particle analysis, other is the field analysis. So when you are in school level, IIT JEE level. So you solve the numerical problem in classical mechanics. Classical mechanics, you have solved many problems in the physics already. वो on which approach you have to solve? वो किस approach से आप solve करते थे? That is your Lagrangian approach. That means you have you draw a free body diagram. If there is a body, so you have to draw a free body diagram, and for the drawing of free body diagram, the body treated as a particle. So that is a Lagrangian approach. That means if you apply the Newton's second law, force is equal to mass into acceleration, that is your Lagrangian description. It is not Eulerian description. That is your Lagrangian description. It is not Eulerian description. So basically, we have a Lagrangian approach, and we converted into the Eulerian approach. That is your known as a operator, that is a total derivative, capital D by dt. So capital D by dt of anything, it is a tool which convert Lagrangian analysis to Eulerian analysis. Eulerian, not Eulerian, Eulerian. Eulerian analysis. So this is the concept of total derivative. So this total derivative, it is a tool which convert Lagrangian approach to the Eulerian approach. And what is this total derivative? This is the summation of the component of a local, that means time derivative, and plus there is a space derivative. Convective part plus temporal part. So convective part, this is the total derivative, which is the include with the convective part plus temporal part, local part. So this d by dt is what? This d by dt is nothing, dou by dou t plus there is a convective part. That means it is like that. U dou u by dou x, dou by dou x, v dou by y plus omega dou by dou z. It is like that. So this is your convective part, and this is temporal part. That is the concept of Lagrangian approach. That Lagrangian approach will convert it into Eulerian approach. So the particle approach is your essentially Lagrangian approach. So we are identify a particle. So that we will solve from the Lagrangian description. How? Please. Now one thing is that if you see this field V is equal to T by X, so you confuse कि sir the formula is wrong. आप कह सकते हो कि sir formula तो wrong है. Velocity होता है X by T, not T by X. Why it is given? It is wrong. No, it is right. This T by X multiply with the some constant, and also the velocity is meter per second, and this is time, so time per meter. The unit is time per meter, but here the unit it is given meter per second. So there is a constant. That constant unit, it is the constant unit is your second square per meter. So meter square per second square. So that meter 1 meter 1 second cancel. It is come out with the meter per second. So there must be a constant quantity here. So don't bother about this expression. Don't say that. Many students say that, sir, the question is wrong. Why? Because see T by X, the unit is meter per second. It is not second per meter. So this is wrong. No, it is right. No problem at all. Okay, just start. So field it is given, velocity field it is given with a, what is that? T by X, and it is in X direction, T by X I meter per second. It is given. This is field. It is given. This is field. Okay. Now, what is condition? What is condition, my dear? Condition it is given at x is equal to 1 when, that is, particle will travel at a distance x when t is equal to 0. We have to find at x is equal to 2 meter what is the velocity of a particle and acceleration of a particle. Clear? Yes or not? That means this is your channel in which this is a particle, these are flowing. Okay, that means we identify a fluid particle. We identify a fluid particle. So this is a particular approach. We identify a fluid particle. So it is a particle approach. And this particle approach is your Lagrangian approach, या Lagrangian description. This particle approach is your Lagrangian description. So, what is the velocity of this particle? dx of the particle by dt. This is your ordinary differentiation. Particle always, now beta, there is one thing always keep in mind. If there is a field, we have to partial derivative. If there is a particle, Lagrangian always a total derivative. Lagrangian is a total derivative, yeah, ordinary derivative, both are same. And Eulerian is a partial derivative. Control volume analysis we have to do with the partial derivative, dou by dou x, dou by dou y, dou by dou z, like that. And Lagrangian approach is a total derivative or ordinary derivative. This is keep in mind. So, if the velocity of the flow, if the velocity of the flow at a point, let's suppose there is any point 1. So, if the velocity of the flow at a point, let's suppose this is a flow velocity. So, let's suppose the velocity of the flow at a point 1 is the velocity of the fluid particle. So, what is the flow velocity? The same as the fluid particle velocity located at that point, at that instant of time. So, in this case, Lagrangian description is same as Eulerian description. That means Lagrangian and Eulerian, they can merge. If the velocity of the field is the same as the velocity of the particle, we cannot identify what is the Lagrangian, what is the Eulerian. Both are the same approach. So, this is a particle. Okay. Now, so if the velocity of the fluid particle is same as the field, so we can write that v is equal to dx by dt, and this v is equal to what? T by x meter per second it is given. Okay. So, we have to integrate x dx, we have to integrate x dx, and x is equal to x, see the x limit is there, x is equal to 1 to x is equal to 1 to x is equal to 2, x is equal to 1 to x is equal to 2, this is x is equal to integration t dt. When the particle is at x is equal to 1, what is the time? 0. When the particle is at x is equal to 2, let's suppose there is any time t. So, if you integrate it, put the value, the x is equal to square root of t square plus 1 meter. This is the relation between the displacement and time. Now, but we have to find time. What is the time? Why? Because at x is equal to 1, the time is 0. At x is equal to 2, what is the time? So that we have to find the acceleration and velocity. So, at x is equal to 2 meter, 2 square is equal to t square plus 1. So, if you solve, this t is equal to 1.732 second. This is the time required to move the particle at x is equal to 1 to x is equal to 2. This is the time. So, what is the velocity of a particle at t is equal to 1.732 second, and that velocity is what beta? T by x, and t is equal to 1.732 divided by x is 2. So, if you find if you find this value, this is your 0.866 meter per second. This is the velocity of a fluid particle at position x is equal to 2 meter. Clear? Now you have to find the acceleration. You have to find the acceleration. So acceleration is what, beta? Is your total derivative dv by dt. Very important. Very important, I am telling you. This is 1D flow. Now this total derivative, how to remove this one? Dou v by dou t. Then we have to write velocity in x component, dou v by dou x. Velocity in y component, dou v by dou y. Velocity in z component, dou v by dou z. Now my dear, this velocity is a function of, we know that field x, y, z and t. Yes or not? But in this question, velocity is the only function of x and t. So it is not a function of y, it is not a function of z, only velocity is the function of x and t. That means this is which type of field, beta? This is your non-uniform one dimension flow. This is your one dimension flow, and the flow is unsteady and non-uniform. Unsteady and non-uniform. Unsteady and non-uniform. So 1D flow. So this is 0. There is no any component. This is 0. There is no any component y direction. Only this one. So acceleration, it is your dou v by dou t plus velocity in x direction, dou v by dou x. Okay. Now dou v by dou t. Dou v by v is what? T by x. Yes or not? T by x meter per second. So dou v by dou t is what? 1 by x. This is the velocity in x direction, t by x. Differentiate with respect to x. So this is minus t by x square. Okay. This is your meter per second square. Okay. Now put this value. So at x is equal to 2 meter and t is equal to 1.732 second. Put this value. So acceleration is 1 by 2 plus. So this is minus t(2) square divided by x cube, 2 to the power q. If you solve this one, this is 0.125 meter per second. Clear? Clear? Huh? So this is also very good problem. So accordingly, you can practice such type of question. Okay, that is done. Is there any problem? Please, you can ask freely. तो बेटा इसमें क्या है, हमने ये सीखा कि क्या लैग्रेंजियन, क्या यूलरियन और कैसे हम अप्लाई करते हैं चीजों को. Okay, if there is any particle approach is there, so how to identify? This is a very good problem. Many students, they can ask such type of problem. Doubt, there is a doubt portal in IMS. There is a doubt portal. On the doubt portal, many times such type of question a student regularly posted. That's why I select this question, so that you have a very much confidence about this one. Now, okay, take the next problem. Yes, this is also very good problem. Why we are taking this problem? Why? Because in the many resources, such type, this problem is wrong. I will show you also. Please read this question. The gap between the gap between a moving circular plate, this is a circular plate which is moving circular plate with the velocity v, and a stationary surface is being continuously reduced. That means it will be moving down, 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 down. That means the gap is continuously reduced. The gap is continuously reduced. As the circular plate comes down, as the circular plate comes down with a uniform velocity, towards the stationary bottom surface, as shown in figure. In this process, while moving the upper plate to the lower plate, and within that there is a sandwich, there is a fluid sandwich, the fluid content within the two plate is flow outward radially. Yes, if there is a two things, one is the lower plate, other upper plate moving, so fluid will flow radially. So it's radially, that means it is a circular disc type. The fluid assumed to be incompressible and inviscid. Okay, there is no any viscous, that means you cannot take a force in that tangential direction, and incompressible, that means continuity equation satisfied, conservation of mass satisfied. So radial velocity, what is the radial velocity at any radius r? At any radius r, what is the radial velocity of the fluid? Number second, the radial acceleration at r is equal to capital R. Okay, so again I will give you a timer. Just start with a, just think that. Time up. Okay, let's start this problem. Now, my dear, what is the approach of this problem? See, my dear, this is the control volume analysis. What is that? There is a stationary plate. One thing, this is the velocity v, continuously moving down. If the velocity, this velocity will cover a distance h. When the plate is moving down, this h is continuously reduced. That means if the time passes, this h will reduce. And this velocity is what, beta? Very important. This velocity is what? This velocity is what? dh by dt, yes or not? First thing. Yes or not? But always remember, this is negative. Yes or not? Why? Because when this plate is moving down, this h is the function of t. H is the function of t. So t will increase, h will decrease, so that there is a negative sign. So this is the velocity. First keep in mind. If you think this one, then it is okay. So this is the velocity v. Okay, h will decrease, time will increase, so velocity is negative, dh by dt. Now, what is the approach? Consider a control volume of a radius r. So let's suppose we are taking a control volume of radius r, okay, coaxially with the plate, okay, and height h. Let's suppose this height is h. This control volume, you are taking this control volume, my dear. Okay. By continuity equation, the fluid skews out the gap. Yes, the fluid, if you plate will move down, this fluid will flow radially outward with the velocity of Vr. with a velocity of VR. Control surface at the same rate at between the plate across the control. That means fluid is out the gap between the plate cross the control volume at the same rate at which it is forced to move by the downward motion of the upper plate. This velocity will out when this plate is moving downward, yes or not? And this plate is moving downward with the velocity v. So what is the rate of the plate moving down? The same rate the fluid will move radially outward. Why? Because fluid is incompressible. So what is the rate of the fluid is moving down? See, this is a fluid particle. Na? 1 second. This is a fluid particle. Na? Yes. This is a fluid particle. Let's suppose this is a fluid particle. This is a fluid particle which is stick to the surface. And let's suppose there is a fluid particle. There is a fluid particle at any instant. Yes. So this fluid particle have a velocity downward, this velocity. So this mass flow rate is the same as the mass flow rate of this one. What is the velocity? Velocity is not same, but the mass flow rate is same. Why? Because density is same. So what is the mass flow rate? Density area into velocity. Okay, density is same. That means mass flow rate at the top is the same as the mass flow rate at the radial location r. What is the mass flow rate of this fluid? The same mass flow rate. So mass flow rate of the top. So this is area into velocity. Area into velocity. So area, let's suppose this area into velocity. What is the control volume area into the velocity of the top is equal to this area, radial area into the velocity VR. Yes or not? You can take like that. And what is the area of this one? Disk pi by 4 r square. Okay, like that. So pi by 4 pi r square. So what is the area? What is the area of this one? So we have to take like that. Again we have to solve. No problem. We can draw this graph again. So this is your plate, top plate. Okay, this is your top plate. And this top plate is moving down. This top plate which are moving down with velocity v, and that v is minus dh by dt. There is a gap. There is a plate which is stationary fixed plate. There is a fixed plate. There is a fixed plate. Now this is your gap. This is your gap H. This is your gap H. Okay. This is a center line. This is a center line. Okay. This is a radius. This is R. And there is any radial location, let's suppose small r, capital R, small r. So this small r, take the control volume. We are taking the control volume. So obviously this is the direction of R. So the fluid which is exit from this control volume, this control volume at any radial location R. This is your VR. At any location VR, this is your radius R. Okay. Obviously this is our control volume. Okay. Now this gap is H. Now, so volume flow rate, that means discharge, you can say that area into velocity. That means volume flow rate of the fluid which is moving moving out radially is equal to volume flow rate of displaced fluid by the moving plate. Moving plate. So, volume flow rate of the moving outward radially. So, there is a circumference area, radial area, circumference C. This is like that. Let's suppose this is a control volume. So, the fluid is moving inside and fluid is moving radially. So, radially moving, this volume flow rate is what? Area into velocity. So, what is the area? The circumference into this radial velocity. Circumference, so what is the circumference? 2 pi r into h, and that is equal to the radial velocity. And what is in this one? What is the cross section? Pi r square. In this one, what is the cross section? Why? Because this fluid is in, and here this is V. So, what is this cross section? Pi r square. Pi r square into V. So, this something cancel, pi cancel, r, 1r cancel. So, what is VR? VR is equal to VR, radial velocity. This R stands for radial velocity, is equal to V into capital R, don't confuse, divided by 2h. This is radial velocity. Is there any problem up to that? Please tell me. This is radial velocity. This is radial velocity. Now, my dear, if you see this radial velocity is the function of R and H. That means if R, that means V constant, this V is uniform now, it is saying that, it is saying uniform speed. So, this is constant, this speed is constant. So, this VR, radial velocity, is a function of R and H. Very important. This radial velocity is a function of R and H variable. And here is the mistake in many books. They are taking the velocity is the function of only R. That is wrong. See this derivation. R is also continuously changing. H is continuously R is continuously increasing. If the plate is moving down, R is continuously increasing. H is decreasing. So, those relative velocity is the function of R and H. This is clear now? 90% there is a mistake in this questions. Okay? So, this is radial velocity. Now, my dear, we have to find the radial component of acceleration. So, this is your field, very important. So, velocity field, if you have simple velocity field, what is the velocity field? And if you analyze the field, that is your Eulerian approach. And Eulerian approach is a control volume analysis. Eulerian approach is a control volume analysis. Lagrangian approach, control mass analysis. Okay. So, just this function is that means radial velocity is a function of R and H. Now, there is a mathematics. Just differentiate partially. So, dVr by dt, that is why, because acceleration we have to find, is equal to dou Vr, you know this thing, dou t, dou Vr by dou r, not dou t, dou r, dou Vr by dou r into dr plus dou Vr by dou h into dh. We can write like that according to the differentiation rule. If there are two functions there, let's suppose a function x is equal to, let's suppose x is equal to any function f y z. how it will write dx, this is not dt, obviously this is not dt, this is not dt, like that, vr, this is only vr, dvr. So how to write? Dx is equal to dou f by dou y into dy plus dou f by dou z into dz, like that. Like that we can write like that. Now my dear, we have to divide both side by time, dvr by dt. So this is what? Radial acceleration, yes or not? So dou vr by dou r into dr by dt plus dou vr by dou h into dh by dt. Simple, simple, don't think much more, load mat lo dimag pe. So this is radial velocity. Now my dear, this dvr by dt, now vr is what? We have already find vr, radial velocity is what beta? Radial velocity is v into r divided by 2h, first part. So if you differentiate with respect to r, this is your v by 2h. Now this dr by dt is what? Radial velocity. What is that? Radial velocity. Radial velocity plus with respect to h. So with respect to h is what? Minus vr divided by 2h square with respect to h, this one. dh by, now this is very important, dh by dt is what? Minus of v. Minus of v. Okay na? Minus of v. Now my dear, then readjust. So ar, radial acceleration. Now my dear, see, v by vr is what? V by 2h, and vr is equal to v into r divided by 2h, and this is minus minus plus v square r by 2h square. Okay, so this is what beta? V square r by 4h square plus v square r by 2h square. Clear? Now if you add, this is 3v square r by 4h square. Now we have to find the acceleration. At r is equal to capital R. Put this r, 3v square capital R divided by 4h square. This is the correct option. This is your correct option. So what is that option? 3v square r by 4h square. 3v square r by 4h square. 3v square by r. Oh, A is the correct answer. And here, this one is the correct answer. Clear? This is clear, my dear? So again we have a some announcement. So this is today's last. Up to that we have this is our last problem for the today, no problem. Why? Because the session is only 8 o'clock. Okay, what is the announcement is that, see, there is a test series plus. This is not only test series, this is test series plus, mind you. What is that? If you buy this test series plus, right now, instantly you have a 20% discount. 20%. What is that? In this test series plus, there is 130 online test. 130 online test. Okay? And you have also benefited with the 33-year GATE PYQ. And in the 33-year GATE PYQ, each question approximately 90% question approximately there is an alternate solution, and approximately 50 to 60% question there is a video solution, QR code is there. And there is also separate book. There are two books. One is the technical book, mechanical, technical, civil, technical, all the technical book, and there is a non-technical book, this which is mathematics and general aptitude. There are two books is there. Also, you have to benefited about the doubt portal. So there is a doubt portal also, and also there is an online revisions and score booster series like that, which is going on. Post gate guide counseling. If you qualify the gate, we have to provide the information which college, which things is important, which university is important, and also interview of PSUs and MX mock test interview. Now this is the things that this is the Telegram group, and this is free of cost. You know this thing. So what is that? In this Telegram group, if you join that, you have that these are the benefit. What is that? Schedule free. That means you have a मतलब time to time आपको एक schedule मिलता रहेगा update. जैसे YouTube का free lecture का उसमें update रहेगा. And in that Telegram there is also what is the today हमने क्या discussion की उसका PDF भी उसी में रहेगा. Important updates related to the what is the important updates like seminar कब होना है, कहाँ होना है, webinar like. Also the notification like a PSU's public sector undertaking, other government job notification will be available here. Expert session of important topic. Let's suppose sometime you are taking a expert session like technical, also there is some non-technical topic like that. So we are taking about that. And also daily cues posted on the Telegram group. Always regularly we are posting the daily cues. So don't worry, don't delay this, join this group and you get the latest information about that. Latest information, okay? That's it all. So if you have any confusion further, any confusion beta, you can just post your doubt on LMS YouTube, or also you can join this so that we can benefit all the things related to the what my personal notes is there. We'll upload in this one. Okay, beta. Up to that. Thank you. Bye bye.